Welcome. In this video, we'll explore a critical aspect of injection molding, designing for optimal mold filling and flow. You will learn how DFM helps to optimize designs for better material flow during injection molding. When designing injection molded plastic parts, understanding how molten plastic fills the mold is essential. During the injection process, the material flows through channels and fills the mold cavity, solidifying into the final part shape. The goal? Uniform material flow. This ensures consistent part quality, avoids defects, and optimizes the manufacturing process. Poor flow design can lead to common defects like air traps, where pockets of air get trapped in the mold, or weld lines where material flow fronts meet but don't fully bond. These weaken the part and create visual blemishes. Well-designed runners ensure balanced flow, helping the part to shrink uniformly, which is one of the major assumptions made in designing an injection mold. Uniform wall thickness is another critical factor in mold filling. Uneven wall thickness can cause race tracking or backfilling, leading to undesirable air traps that can result in non-fills or burns. It can also lead to hesitations or accelerations in flow that can cause unwanted visible flow lines. Other design flaws to watch out for include sink marks caused by poor rib design or inability to pack those areas because of poor gate placement. Poor rib design can appear where draft angles are misapplied. Adding a slight taper to walls is necessary for easier part ejection from the mold without damaging its surface. Taller ribs are particularly vulnerable to flow problems. The base of the ribs can be too thick, leading to sink marks, and the top can be too thin, leading to non-fills. In summary, designing for mold filling and flow is about more than just getting the material into the mold. It's about ensuring smooth, uniform flow for high-quality parts. Keep geometry simple and allow for optimal gate placement. Prioritizing mold filling considerations in DFM is very important. By doing so, you'll avoid common issues and create parts that are not only functional but also cost-effective to manufacture.